We see construction sites all the time, and we tend to think of them as these self-contained bubbles of activity. But what if the real story, the one with the biggest impact, is actually what's escaping from beyond the fence? Hello from Metricom, and welcome to The Explainer. Today, we're going to peel back the layers on how construction contamination is a bigger threat to biodiversity than you might think, and more importantly, what we can actually do about it. So let's reframe how we think about this. It's not really about whether a work site looks neat and tidy. The real question, the one that truly matters for the environment, is this. Can the contaminants on that site, even the ones you can't see, find a way to move into the surrounding ecosystem? And that leads us right into our first point. Because a site can look perfectly fine, totally under control, but the danger is often invisible, hiding just beneath the surface or hitching a ride on the wind and rain. I mean, picture it, right? You've got your perimeter fence, materials are stacked, everything looks organized, it feels controlled. But here's the thing. Pollutants, they just don't care about fences. We're talking about fine sediment, tiny droplets of fuel, chemical residue. They can all find a pathway out and start a journey that ends in our natural environment. And if you look here, you can see just how many everyday activities can become a source of pollution if the right controls aren't in place. I mean, it's everything from the big stuff, like excavation and demolition, to something as routine as storing fuel. And sometimes the problem is already there waiting for you, like contaminated groundwater or, old waste that was buried decades ago. This is a huge issue, especially on what we call brownfield sites. Think of these as properties with a past life, maybe an old factory, a gas station, or workshop. The contamination isn't even from the new construction project. It's a legacy problem just sitting there, and the new work can accidentally wake it up and spread it around. It really adds a whole other level of challenge. Okay, so if the pollution is there, how does it get from point A to point B? Because it's definitely not just sitting still. It follows specific pathways, and understanding these pathways is absolutely key to stopping it in its tracks. And this chart shows the main escape routes perfectly. The biggest one, no surprise, is stormwater runoff. A heavy rain comes, washes over the site, and carries all sorts of nasty stuff right into the drains and local streams. But pollution is sneaky. It also travels underground through groundwater, gets carried for miles as dust on the wind, or even gets pumped out during dewatering operations. So, what's the big deal? Let's talk about the real-world consequences, because this isn't just some abstract environmental issue. It is a massive business risk. Just look at this breakdown. It's really two sides of the same coin. On the left, you've got the damage to nature, sediment that literally smothers riverbeds, chemicals that poison the soil, and toxins that work their way up the food chain. And on the right, direct hits to the business, crippling fines, stop work orders that bring a project to a screeching halt, and of course, a damaged reputation. They are completely linked. And to really bring this home, just look at this number, 1. 1 pH point, that's it. The wash water from concrete work can be super alkaline. If that gets into a local stream, an increase of just 1 pH point is enough to seriously harm or even kill fish and other aquatic life. It's such a small chemical change with an absolutely devastating biological impact. So with all this complexity, how do you manage the risk? Well, professionals use a really clear and logical framework to think about it. It's called the source, pathway, receptor model. It's actually a pretty simple but powerful way to look at it. First, you identify the source. That could be the leaky fuel tank or a pile of contaminated soil. Second, you figure out the pathway, how it can travel, like through that stormwater runoff we talked about. And third, you identify the receptor, the thing that could be harmed, like a nearby wetland, a stream, or a protected forest. The goal is to break any link in that chain. If you can do that, you stop the harm before it happens. And it's so important to remember that when we say receptor, we're not just talking about cute, furry animals. A receptor can be the microscopic organisms in the soil that keep it fertile. It can be the plants, the wetlands, the groundwater we drink from. It's the entire system that keeps that local environment healthy and functioning. All right, so we get the problem, we get the framework. Now for the good part. What do we actually do about it? Let's talk about the solutions. It really all comes down to being proactive. This is basically the strategic playbook you should run before a single shovel even hits the ground. It's about doing your homework. What's this site's history? Then you test the soil and water to see what you're really dealing with. From there, you map out that whole source pathway receptor chain and plan your controls. The real key here is having a plan for remediation before you ever find a problem. And this brings it right down to the ground level, the practical, everyday stuff that actually breaks that chain. We're talking about simple but effective things like sediment fences, proper washout areas for concrete trucks, and making sure fuel and chemicals are stored correctly. It's all about making these controls a non-negotiable part of the daily routine, not just an afterthought. So, if we're going to wrap this all up, it really boils down to this one powerful idea. Protecting biodiversity isn't just about what you do on your site. It's about understanding the journey a pollutant can take. Because once we understand how contamination moves, we can build the roadblocks to stop it and protect that intricate web of life that depends on a clean, healthy environment. The project itself might be temporary, but its impact, for better or for worse, can last a very, very long time.